Hello, students. Now that you have read the basics of circular economy, the concept of loop and butterfly diagram, it's time to listen to Edward's view on it. Edward Clarence Smith has over 40 years of experience working for international organizations, government, private sector, and environmental NGOs across the world. He is an expert in environmental sector and passionate about circular economies. His current efforts are to equip and enable next generations to heal our planet and build a sustainable future via consultative and knowledge sharing engagement across governments, businesses, and educational institutions.
There's other diagrams out there, but I think this one gets the overall picture pretty well. So now the first thing that we notice about this diagram, right, is that it has two parts to it, the two wings of the butterfly, no? And there's a very good reason why this diagram makes this primary fundamental distinction between the way we cycle biological materials through the biological cycles and the way we cycle technical materials through the technical cycles. Now, what do we mean by biological and technical materials? This is not a definition, this is more just a sort of reasonable description, shall we say, of what we mean. In terms of biological materials, we'd be talking about food and drink. That would include, of course, animal feed. We'd be talking about wood, of course, which has been with us for hundreds of thousands, perhaps millions of years, but also other lignocellulosic biomass, for instance, in your part of the world, or India. If you're all from India, bamboo is an important lignocellulosic biomass and has been for hundreds of thousands of years. Then there are the fiber producing biomass. Cotton is the big one, king cotton, but there are again many others which may have regional importance. There's biomass which is offering us other products and other services, tobacco, which is perhaps not one that we want to promote too much anymore, medicinal plants, and so on. And then, of course, in many parts of the world still, work animals are an important part of our economies, oxen, buffalo, horses, mules, etc. Those too are biological materials and they form part of the biological flows in our societies and our economies. And then you can add also perhaps biomass, which is offering us pleasure, flowers, gardens, plants, and so on, but also house pets. And then on the technical side, technical materials is basically metals, glass, ceramics, bricks, concrete. Fossil fuels, of course, is a technical material. Artificial chemicals, that is to say chemicals which are not found or found in very small quantities in the natural world. That includes many pesticides, many pharmaceuticals, many dyes. In fact, I would say many of the hundreds of thousands of chemicals in commercial use today are artificial chemicals. They are not chemicals that you will find in the natural environment. And then I would also add to technical materials, plastics and their cousins, the synthetic textiles. And there may be others which I've missed. But summarizing, biological materials are materials which are extracted from the natural environment, the so-called biota, and can be broken down naturally in the biota. Technical materials, on the other hand, cannot be so broken down in the biota and can be toxic to the biota. So that's the primary distinction between these biological and technical materials. So now, what does that tell us about circularity? And for that, I want to go back to an even simpler diagram, which I made up. This is not something that I picked from somewhere else. And let's start with linear economy. So very simplified. Currently, the flow of materials looks like this in our economies. We have the economy, which is more or less equivalent to a country in most cases. Those economies are embedded in the environment. They are an integral part of the environment. It's always important to remember that. Our economies are completely reliant at the end of the day on the environment in which they are embedded. Our economies extract materials, both biological materials through farming as well as technical materials through mining they extract those materials, they bring them into the economy, they make products, we use those products, and then finally we dispose of those products and various other materials along the way. We emit, we discharge, we dump back into the environment. Now, a circular economy, then, what would it look like? Well, for technical materials, we would want the flow of materials to look like this. So again, we have our economy, it's embedded in the environment, but now you see the flows are actually imprisoned, as it were, within the economy. Most of the materials are flowing only within the economy. Now, because no system is 100% efficient, there is always a little bit of leakage in some form or other, and therefore there's always going to be the need for a little bit of top-up from mining of technical materials. Essentially, in these COVID times, it seems to be a relevant way of putting it, we are quarantining our technical materials in our economy, and we want as little as possible of these materials to escape into the environment. Now, for biological materials, we have a different kind of situation. Here we have the economy again, embedded in the environment. And here, though, you'll see that the flows of materials are actually still leaving the economy, but in such a way that we can recycle and reuse those materials and bring them back into the economy through fresh, new biological materials. We are therefore, in this case, deliberately using the biota's natural recycling systems to recycle biological materials. And that's why it's important, of course, that anything that goes into this flow should not be poisonous, should not be toxic to the biota, which we are asking kindly, please do this job of recycling for us. Now, this brings us this distinction between the biological cycles, biological materials and technical materials, leads us to another distinction, which we see very clearly in the butterfly diagram, which is that we have a distinction between the consumer and the user. These are two terms which we often use interchangeably, but actually, at least for this, it's important to distinguish between the two. Now, that really means distinguishing between what we mean by use and consumption. So when we say that a product is used, it still exists after it has been used. I mean, for instance, this computer, which I am using at the moment to give this lecture to you, will continue to exist after I have finished giving you the lecture. On the other hand, products which are consumed, they disappear. They are destroyed during use. For instance, food and drink. When we eat the food, that food disappears. It's no longer, I no longer have my steak, I no longer have my French fries, or to be a little bit more on the sort of healthy side, I no longer have any salad. It's the same for pharmaceuticals. When I swallow my pharmaceuticals, those pharmaceuticals are destroyed to do their job in my body. Now, most consumed products are made from biological materials, which is why in the butterfly diagram, the consumer is sitting on the biological cycle. Now, okay, so if the products which are consumed disappear or are destroyed, what are we talking about then in terms of circularity for consumed products? Because we're definitely not cycling the product. What is it that we're cycling? Well, the answer to that is that we are cycling the nutrients, primarily the nitrogen, the phosphorus, the potassium, and so on, that are embedded in those biological materials, as well as the carbon, which is also embedded in those products. And it's they that are being cycled back to the soil to maintain soil health and to reduce the need for artificial inputs like fertilizers and so on. Now, I said that most products that are consumed are biological, but not all of them. Not all products which are consumed are made with biological materials. For instance, very simple example, toothpaste. Toothpaste is not a biological material, and yet it is consumed when I brush my teeth. And a good number of the products which are currently consumed by us are toxic to the environment. The obvious one is pesticides. They are made to be deliberately toxic to the environment, but there are many others. If you just mentally run through many of the products that sit, for instance, in your kitchen under the sink, a lot of those are actually toxic. So this distinction here leads to some very important product design principles, fundamental product design principles. If you as a product designer, if you're a product designer, you have to decide if your product in a circular economy is going to follow the biological cycle or if it's going to follow the technical cycle. Are you making a product which is going to be consumed or is it going to be used? Now, if it's going to be consumed, you have to be very careful that the biological or other materials that you use in that product will not be toxic to the biota. If they will be, then you should really be considering making a product that is used, that will go through the technical cycles. That will be, because those materials then will be quarantined off from the natural environment. Another important principle is that you mustn't mix biological materials with technical materials in your product design. Because if you do that, then you, in a circular economy, you risk to contaminate either the technical cycle, if you decide to go that way with your product, with the biological materials that are in them, or more importantly, you risk to contaminate the biological cycles with the technical materials that are in them. The other thing is that you can decide that biological materials will follow the technical cycle. For instance, wooden furniture or paper would follow the technical cycles, but it can't be the other way around. There are no technical materials which should be designed to go into the biological cycles. All right, let's go back to this diagram and let's see what else it's telling us. Let's look at this little comment down here, leakage to be minimized. And that's really about, what is the role ultimately then of waste and pollution in a circular economy. This diagram focuses on solid waste and it focuses on energy recovery and landfills. But I think that this idea of leakage is valid for all pollution and all waste that is generated in our economies. No, so ideally, of course, in a circular economy, because it is circular, because we are quarantining these materials, there should be no waste, no pollution, no emissions of technical materials. Ideally. Well, that then would mean, in the ideal case, that we would have no need anymore for landfills or for incinerators or for chimneys or for discharge pipes into rivers, and so on and so on. But life is not like that, right? An economy is never going to be 100% circular. There's always going to be some inefficiencies in the system. So the goal is to minimize leakage into nature. We understand that there is going to be some, but we absolutely want to minimize it. And of course, that means that we will continue to have a waste disposal and pollution control industry, but it should be much, much smaller than it is today. Now let's look at the other end of this. We've talked about leakage down here on the exit side. What about on the entry side? What is this diagram telling us about mining? Again, ideally, all the technical materials, now this is really focused on the technical materials, all the technical materials in a circular economy should come from reusing what we already have in use. So again, in the ideal case, there would be no mining of virgin technical raw materials. Mining as an industry in a circular economy should disappear in the ideal case. But again, no economy is going to be 100% efficient. So there'll always be some leakage, and if there's some leakage of technical materials, there will need to be some mining to top up those material flows in our economies. Also, in the case specifically of the developing economies, they still need to build up their material stocks in the economy. their housing stocks, their infrastructure, their stocks of essential products, however one wants to define that, and so on. There's still a need to build those up to meet other goals more on the social side, shall we say, the social SDGs. So, in that case, mined raw technical materials should continue to enter their economies specifically for some time to come. And so the goal in this case really is to taper off the mining of technical raw materials until only a small amount is required to make up for leakage, the top up that I've been talking about. Now, there's another important principle here which needs to be stressed. The term circular economy is actually a little bit of a misnomer, because it leads many people to think that a circular economy is actually just a recycling economy, but it's not. Because in a circular economy, we want not only to reuse materials again and again, but also to make do with less materials in the first place. And why is that? Because we have 8 billion people on the planet at the moment. That is going to go, if predictions are correct, to 11 billion by the end of this century. In that kind of scenario, we will never decouple economic growth and well-being from the consumption of virgin resources and the accompanying environmental impacts unless we do our best to reduce the amount of materials that our economies need. And that is why, and let me just explain perhaps why it's so important to do this decoupling, to get away from the extraction of virgin resources, and not just the technical mining part, but also on the farming side. Here's a diagram which shows the impacts of resource extraction in general on the environment. 55% of climate change impacts can probably be attributed to resource extraction, much of it in the mining. 30% of particulate matter health impacts can be attributed to resource extraction. Again, a good part of that in mining. 95% of water stress can be attributed to resource extraction. In this case, much of it from biomass extraction, farming for the most part, agriculture. And 95% of biodiversity loss is due to land use is also there. And again, much of that is from our extraction of biomass. So that's why, I didn't say so before, but now I make it clear in my little diagrams, not only are we seeing these flows going circular in these two types of circular economies, but also the arrows are getting much skinnier than this one, which is what I had in the linear economy. So not only do we circularize our flows, but we have much less material flowing through our economies in the first place. Now, to reach these two objectives, that materials have to go around and around, but we also have to have less materials in the first place, we have to implement three broad strategies. We have to narrow the flows by using less materials and energy to make, but also to use products and to deliver services. We have to slow down flows by extending the useful life of products, but also of product parts. And we have to finally close the loops by recycling used product parts and used materials back into manufacturing or into agriculture and other primary sectors if we're dealing with biological materials. So in the butterfly diagram, where are the primary location of these three strategies? They'll be used in some degree everywhere, but where are they primarily used? Or where are they primarily most important? As far as narrowing flows is concerned, it really is important in the primary production, in farming and so on, but also, of course, in manufacture, but also in the distribution sector, and also in use and consumption. So in all of this part, an important strategy will be to narrow flows. Slowing down flows is really something that is more for the technical materials, and it will happen here through maintenance, through reuse, and through remanufacturing. And then the third one, closing the loops, will of course happen here in recycling, the recycling that we all know about, but also in cascading, which is another form of loop closure, as well for biological materials here through recycling of the nutrients, and well here also of the chemicals that are embedded in biological waste flows. So let's now look at this narrowing flow strategy in a little bit more detail. So again, narrowing flows means using less materials and less energy to make and use the products that we have and to deliver services. And it's implemented then more specifically through efficiency improvements, the kind of things that we're all very familiar with, by turning residues and waste into byproducts, and by intensifying use. That is to say, by extracting more use out of each product through sharing, which will therefore then reduce the overall pool of products that we need. Now, where will the responsibilities lie in all the various stakeholders in the circular economy? So farmers and the other primary producers will, for instance, reduce harvest and post-harvest losses, and they will turn their residues into products, their agricultural residues. Manufacturers will, for instance, implement cleaner production, resource efficiency and cleaner production. Users and consumers, and by that I mean not just households, not just you and me, but also institutions like schools, like government ministries, companies also. Companies not only produce products, but they also use a lot of materials to help in the processing of those products. Businesses more generally, banks for instance, can narrow their flows. And of course, primary producers are also users. They use pesticides, they use fuel for their tractors and so on and so forth. These users and consumers, all of us essentially in the economy, we will, for instance, purchase fit for purpose products, i.e. we will buy products that do what we want and not a whole lot more. We will use our products efficiently and we will share products. I think efficiency and turning residues into byproducts is relatively sort of understood, so I'll skip those. And I just want to say a few words about sharing, intensifying use. The fact of the matter is, and we have to remember this, that during their productive life, our goods and our products often have very low utilization rates. And the more developed the country, the more that tends to be the case. We are essentially underusing our products. For instance, the EU did a study on cars, and they found that a typical European car is parked 92% of the time. 92% of the time it's just parked, doing nothing. Of the remaining 8%, 1% of the time the car is still sitting, but this time in traffic jams. Another 1.6%, it's desperately looking for parking. And it's only 5% of the time that a car is being used for what it was made to do, which was to get you from A to B. That's a terrific waste of all of the materials and all of the energy that went to make this very complex piece of equipment. And it's simply not being used for what it was made to do. It's such a waste of all of those inputs that went into it. And on top of it, in a car, again in Europe, the average European car has 5 seats, but it only carries on average 1.5 people per trip. And in fact, in Europe, if you stand on a street corner during rush hour and look at the cars that are going by, you will see that most of the cars only have 1 person sitting in them. Again, a tremendous waste of all of the resources that went into that. Same with buildings. 60% of European offices are not used even in working hours. And this was before COVID. And 50% of residential dwellers report that they live in too much space. Now, that is very definitely a problem of the developed countries. And what we need to do for a circular economy, it's one of the strategies, one of the implementation strategies that we have at our command, is to squeeze more use out of each product we make, so that at the end of the day, we get, as an economy, we get just as much use out of that, but we can do it with less products overall, which of course then narrows the flows. Now, generally speaking, we share products in three different ways. There's the so-called product service economy, where someone owns a product, doesn't actually use the product itself, and allows others, though, to use it for a fee. So car hire companies, for instance, or laundromats, or photo booths, or I'm sure you can sit there and you can think of many, where essentially one person owns something and then allows others to use that for a fee. And then we have on-demand economy. Again, someone owns a product and it's the owner who uses it to offer a service to others, but only does that when the service is requested. The typical example of this is taxis. Generally speaking, a taxi should just be sitting there waiting for clients, and the car is only used when somebody asks for the taxi service. But plumbers, for instance, and many other people who offer home services, they have a lot of tools, but those tools will only be used when someone asks for the service. And then we have the sharing economy, which is where someone, again, the owner, regularly uses a product, but it's underused, that famous one person in a car during rush hour. But we'll share that product, possibly for money, not necessarily, if there's an interest from other people. And a classic case of this is carpooling. Now, these things have existed forever. But now what we're seeing internet-based examples of all of these strategies coming up. For instance, the car, the motorbike, the bicycle sharing programs that are popping up in many, many cities all around the world. That's an example of product service economy. Uber is an example, more or less, of the on-demand economy. There's a lot of arguments about this, but let's say that Uber is an example of this. Carpooling, internet-based carpooling, is an example of sharing economy. Now, the interesting thing about internet-based schemes, as far as circular economies is concerned, is that they tend to reduce the so-called transaction costs of sharing. That is to say, all of the costs, the trouble, and the risks incurred. And therefore, in that way, they can greatly increase the pool of potential sharers, and hopefully then we can have even more sharing than what is happening at the moment. Now let's have a look at the slowing down flow strategy. So slowing down again means extending the useful life of products and product parts, not just products, and can be implemented through the careful use by each of us of our products, the maintenance of those products, the repair of those products, and the second-hand use of the products. So when I, as shall we say, the primary user, no longer need to use that product, then I pass it on to someone else who can continue to use it. And then it can also be implemented through remanufacturing and refurbishing, which is essentially a way of giving a new life to workable product parts. Now, again, this strategy, I'll say it again, is primarily concerned with products that are made of technical materials. It's not really terribly relevant with products made of biological materials. Now, all users, and again, remember, we are all users throughout the economy. We can carefully maintain, and repair our products and equipment. That can be our responsibility in this part of the strategy. All users can, again, purchase second-hand products instead of new products, and the opposite side of that, can put their products, once they no longer need them, into the second-hand cycle when they're finished with them. And then the users of more complex products, because remanufacturing and refurbishing are really a strategy that you use for relatively complex products, users of those kinds of products can, first of all, purchase remanufactured or refurbished products rather than new products, and they can put their products into the remanufacturing or refurbishing cycle when they no longer need them. So there's both a demand and a supply part to this. I want to introduce it to the idea of use value and maintaining use value, because extending the useful life of products is really about maintaining their use value for as long as possible. Because when you make a product, you are injecting use value into it. It's become useful to the user. And in general, the more complicated the product, the more amount of use one can get out of it. For instance, the use I can get out of a spoon is relatively simple. It's to move some liquid from a bowl to my mouth. But something like this computer can offer me much more use than that. And so more complex products will generally contain more use value. Now, just note here that this is not monetary value that I'm talking about. It's the amount of use that you can get out of a product. I mean, there is a rough correlation between the amount of use you can get out of a product and its purchase price, but I'm really talking about use value. Now, this little diagram here shows how a product's use value might look like over time in an economy. So we have use value here on the y-axis, time on the x-axis. We've got some materials, hopefully recycled materials. They go through a production phase very rapidly, and essentially in production, you're taking a series of amorphous materials and you are making them into a useful product. And so you have a product here which begins to get used. With time, it loses use value because it gets old, doesn't work so well. You do a little bit of maintenance, that brings that back, the use value up a bit, again begins to drop. Then something breaks apart, then it has no use value at all because you can't use it anymore. So you do some repair and that will bring you back up to a level of use value, and you'll continue to use it. And then maybe you'll pass it on to a second user who will pass it on to a third user. And all this time, this product is getting older and older, and it's not working. It's beginning to work less and less well. And finally, there comes a time when it is time to recycle it. And therefore, through maintenance, through repair, and through reuse, you have extended the life of this product. And you have extended this use value. You have maintained its use value for as long as possible. Another thing I want to mention here is, especially on this side of extending the useful life of products, it's also about keeping the cycles as short as possible. The longer the cycle, the more energy and materials will probably be needed to run that cycle. So for instance, down here, if you're using a product carefully, it means that no cycling is required. There's zero extra energy and material use needed. Now, if you go into maintenance and repair, hopefully that can be done locally and will normally require modest material and energy inputs. Secondhand use can also be done locally and also will require, generally speaking, modest material and energy inputs to make that cycle work. Remanufacturing and refurbishing, that will normally be done more on a regional, if maybe even global level, similar actually to recycling. But again, compared to recycling, it will probably be using less material and less energy inputs than recycling to make that cycle happen. So there is, if you want, also an energy and material penalty if you just go straight to recycling and you don't go through these various intermediary cycles. Let me now just make a few comments about some of these particular circular economy practices. On repair, I think the thing we have to remember is that for it to be a viable option, one very major condition must be met. It must be considerably cheaper to repair a product than to buy it new. For instance, again, in Europe, they did a survey, and people said they would repair their products if the cost didn't exceed, let's say, a third to half of the price of a new product. Now, what does that mean? How do we keep it considerably cheaper? Well, it means, first of all, that products must be designed in the first place so that they can be repaired easily, so that they can be taken apart quickly. It's easy to extract the parts. You don't break everything else while you're doing that, etc., etc. Also, manufacturers mustn't be allowed to monopolize repair. There must be, because if they monopolize repair, of course, they'll make the price, they'll increase the price. And it's in a way not in their interest to have repair. They would prefer you to give up and buy new. So we must ensure that there are sufficient, technically proficient, they have to be able to do the job, third-party repairers that are available, and they must have access to the necessary spare parts, the manuals, the specialized tools if needed, etc., etc. Manufacturers must also make spare parts available for a long period and at a reasonable cost. One of the strategies that manufacturers have is that they only offer spare parts for a short period of time. If you want to repair after that, sorry, no spare parts. And they often make spare parts exceedingly expensive. And then governments can also set cheaper VAT or sales tax rates for repair work, or they can allow deductions in income tax returns for repair work, again, to make repair cheaper. And I have to say that repair, at least in the developed countries, is a very hot issue right now. Many countries in the EU and many of the individual states in the US, for instance, are pushing for legislation on the right to repair, on the right of us consumers to be able to repair our products relatively cheaply. And of course, as you can imagine, there's a fair amount of pushback from the manufacturers. What about reuse? What can we say about that? Now, I think the important thing to remember about reuse is essentially, we're talking about trade in secondhand goods. So let's have a look a little bit at that. Markets for secondhand goods, both formal markets as well as informal markets, you know, sort of flea markets and that kind of thing, they are very well developed in, I would say, all countries. Complex and therefore expensive products tend to have well-formalized second-hand markets. For instance, airplanes, you don't buy airplanes in a flea market. Medical equipment, real estate, of course. Real estate goes through many uses, each piece of real estate. Cars, the market in used cars is much bigger than a market in new cars. Certain other products have also strong second-hand markets, but they tend to be both in the formal as well as the informal. Furniture, clothes, for instance, you can buy in second-hand shops, but also you can buy in flea markets or off your friends or whatever it happens to be. What are some of the common barriers to the buying and selling of second-hand products? Well, the biggest one, of course, is a buyer's lack of trust in the quality of used products. They're never really sure that this product is going to work properly. And if the price of the used product, again, like in repair, is too close to the new product, buyers prefer to buy new. I mean, especially if there's a lack of trust in the quality, you know, you say, well, I'll pay some more, but at least I'll be safe and I'll know that it works. Now, where fashions or trends change quickly, and this is particularly the case for clothes and electronics, then used products become obsolescent quickly. And obsolescent here, not in the sense of technically obsolescent. They work perfectly well. It's just that people don't want them because they're no longer in fashion or they're no longer the latest trend. And in this case, changes to software is particularly problematical because that is leading to a very much faster obsolescence in terms of fashions and trends. And then, of course, that's on the buying side. On the selling side, producers resist second-hand markets because they fear that it will reduce their sales of new products, which is not necessarily the case, because you can actually have two different market segments. You can have one market segment where you can sell new very easily, and then another market segment where you can sell secondhand very easily. So basically, if we want to encourage reuse, governments are going to need to implement policies to overcome all of these barriers and any others that there may be. Let's also remember that there is a strong international trade in secondhand goods, as there is in new goods. And this trade tends to be mostly in the opposite direction to new goods, which is from developing to developed. It's mostly from developed to developing countries. And many developing countries have barriers of one form or another to the imports of secondhand goods. And I think that part of the circular economy dialogue is going to have to be, what do we do about that? What about reuse? Oh, sorry, that should be remanufacturing. Okay, let's remember that remanufacturing is a way to recycle and reuse parts rather than material. Now, for those of you who are not very familiar with remanufacturing, essentially what it is that you take a used product, a so-called core, and that core is completely disassembled. The parts are all cleaned, any worn or broken parts are replaced, software is updated, and everything is then reassembled. Now, this is where it becomes key. The reassembled product is tested to ensure that it meets or exceeds original equipment manufacturer's performance specifications. That is to say, you are making a remanufactured product is as good as a new product. That's very important to remember. In fact, it might even be better. And as a reflection of that, the remanufactured product will carry a warranty that is equivalent to that of a new product. And, you know, in a way, this comes to the issue of, well, I mean, I'm not sure about the quality of this used product. Well, you get a warranty which is as good as if you bought something new. And because a remanufactured product is equivalent to a new product, the OEMs often make it an integral part of their business model. It is an integral part of their business model to remanufacture a certain number of their products. Now, refurbishing then and reconditioning, there are various terms floating around here, and there's some confusion, I have to say. Refurbishing is a less high quality version of remanufacturing, and consequently the warranty is generally not so good, and the OEMs will often not be involved in refurbishing. Again, remanufacturing and refurbishing, they're global businesses, mostly at the moment located in developed countries. I think that there is an opportunity here for developing countries. These jobs are not low skill, they're high skill, so this is good business for developing countries. But again, there are various barriers to international trade to refurbished and remanufactured products. And again, then we have to have a dialogue if we want to promote the circular economy on what to do about those barriers. Let's have a look at the closed loop strategies now. And we're going to look at these three things. Now, again, closing loops means recycling not just materials, but also used product parts back into manufacturing, and then materials into manufacturing or into agriculture if we're talking about biological materials. Remember that in remanufacturing and refurbishing and any recycling activities which require disassembly, these can give rise to a stream of reusable parts. So you can have recycling of parts, and it's better to recycle a product part because remember, their value has gone into that part. Materials and energy have been processed to make that part. And so the longer you can maintain that value, the better it is. And so it is better to recycle a reusable part rather than just smash up that part and reuse the materials which it is made of. Now, recycling of technical materials will give rise to streams of recyclate, which is the stream that you are focusing on in your recycling business. Recycling business will generate the material that you're actually getting to be recycled, but it'll also generate various other things. So it'll give rise to streams of recyclate for reuse, ideally in products of the same quality as the original products. So the best we want recycle plastics, the products that you then make with the recycled plastic are as of good a quality as the original products that were made from virgin plastics. And that, unfortunately, is not the case at the moment. Cascading is a way actually of reusing materials that make up a product in products that are of lesser quality. It can be a strategy that makes sense in certain situations. And composting and anaerobic digestion will give rise to streams of compost and digestate, which can then be restored to the land. Now, this is all done by companies that this is their business. But other entities in the economy that are not in the loop closure business, we still have important roles to play in closing the loops. Farmers and other primary producers will spread the compost and digest it on their land. Manufacturers will use the recyclate as their raw material, and all users will ensure that their used products go into the right recycling stream. Recycling. The important thing here is that we go from recyclable, everything is recyclable, to recycled. And a waste material can only go from being recyclable to really being recycled when three conditions are met. There's a cost-effective recycling technology process for it. There's a potential market for the recycling which the process produces, and the price of that recycling is lower than the equivalent virgin material. At the moment, for instance, in plastic, we have a big problem here. And the role of government then is to make sure in a circular economy that all three conditions exist. Cascading, just an example from the textile industry. Pair of jeans, you do go through a first use as a pair of jeans, then you could do some technical recycling, but we'll forget about that. We'll go over here. The textiles could be used as furniture stuffing, less higher quality use. So it goes through a use phase as furniture, then the furniture again gets thrown away, but the stuffing, the fibers can be used again at an even lower level of quality as insulation fiber, and then can go through a final use as insulation material. Composting and anaerobic digestion. Let's just remember that agriculture and forestry, they impoverish soils because they extract nutrients and soil carbon. So we have a problem on the input side. On the output side, we have a lot of biomass waste, which is poorly managed and is creating environmental and health problems. Now, in terms of the impoverishment of soils, in modern times, we've maintained soil fertility by the massive use of artificial fertilizers, and this is completely unsustainable. So we need to maintain soil fertility and regenerate our soils naturally by recycling our biomass waste safely back to the land. And we can do that by harnessing the Earth's natural recycling systems, bacteria primarily, in operations on industrial scale. We're not talking about artisanal stuff here. Composting and anaerobic digestion. Composting is an aerobic process. This is what it could look like. Anaerobic digestion is one that we all know, but we all know really for the biogas. We often think of anaerobic digestion as a producer of biogas. Well, actually, in a circular economy, what we're really much more interested in is what's left over, the digestate. The biogas is a useful and interesting byproduct, but this is what we're interested in, because this is what will go back onto the land and restore our soils. Extraction of biochemical feedstock very quickly. Hopefully, with the end of fossil fuels, we're going to need a new feedstock for the organic chemicals industry. Otherwise, we'll have no organic chemicals industry. Recycled biomass can be that feedstock, and industrial plants that use biomass as feedstock are commonly called biorefineries. Here we have, if you want, an overall picture of what we could be talking about, different types of biomass feedstock. Been a lot of arguments up here about, food versus fuels. We need to get away from that, need to get down here. These are the processes that we can use. Anaerobic digestion is one, but there are many others that can be used. And this is a series of the products that could be generated from these biorefineries. we should be perhaps more up here, higher value added stuff, and less down here, which is low value added stuff. Final word on renewable energy. I mean, let's remember that just as in a linear economy, a circular economy cannot work without consuming energy. So no economy will be fully circular unless the energy it uses is fully renewable. Much of the linearity in our economies is due to our use of fuels, of fossil fuels. Now, the transition to renewable energy is a wholly separate area of technology development and policy making, and it must go on then in parallel to the transition to the circular economy. And remember, though, that any equipment that is used to produce renewable energy will be subject to the same cycles as any other technical material and to the same strategies to circularize. With that, I stop. Sorry, I've been a bit long.